Okay, so we have this circular loop of radius 45 centimeters. It's got 157 turns in it, and it's vertical with its axis along the east-west line. So if we imagine east is coming out of the screen at us, right? And this thing has a clockwise current on it when viewed from the east, right? So east is coming out at us. We're looking west at the sunset. Um, its magnetic field is due north, right? So that's north, and so and parallel to the ground, right? Because this current is rotating clockwise by the right-hand rule, the dipole moment for it is pointed into the screen, right? That's into the screen, and we're looking for the torque on the loop taking upwards to be positive, right? Well, torque on the loop, right, goes as mu, the dipole moment, cross B, goes as mu cross B. We'll get there in a second. So if you take your thumb and point it into the screen, and you take your forefinger and point it north, right, and this is on your right hand, right, it's the right hand rule, thumb into the screen, forefinger pointed north, then your middle finger would be pointed down. So the net torque, right, the torque on this is going to be down, right? Magnetic field is to the north. The magnetic dipole moment is into the screen. Mu cross B is going to give us a torque downward. So we're going to go through and we're going to calculate the magnitude, but here it says up is positive, and so we're going to, at the end, we're going to put a negative sign on this. All right. All right. So let's start with what is the equation for the magnitude of the dipole moment of a current loop? Well, mu is simply the number of loops times the area of the loop times the current. All right. Well, we know the current, we know the number of loops, and we know that the area is pi r squared. So we know the area. And we know then that the torque, the magnitude of the torque. Let me write the full equation. Tau, tau vec equals mu vec cross the magnetic field. All right, which in this case the magnitude is going to be just mu b, right? So that's going to be pi r squared n I b is going to be the magnitude, and we know that from the direction taking the torque to be positive going up, right? We know that this at the end of the day is going to be negative. From the right hand rule works out to be negative, and so this ends up being the equation for the torque. We've got to make sure that 45 is in meters, so that's 0.45. Let's pull up Excel and let's do some calculations, right? All right. 157 turns, 0.45 meters. The I dot dot N I B. Okay, 3 times 10 to the minus fifth, right? So the torque is going to be minus pi times R. That's N. Sorry. Minus pi times R squared times N. I haven't put in the current. So current is 105 amps, right? That's a big current. All right, so we've got minus pi times r squared times n times I times b. All right, so minus 3.15 times 10 to the minus 1, or minus 0.315 is the torque. Minus 0.315, and that's Newton meters. Newton meters. All right. And that's it for this this problem. Uh, Hopefully that was clear enough.